Okay, so friends, now that we learned how to find common factors among two numbers, we're now going to learn how to find the greatest common factor among numbers. It could be two numbers, it could be three numbers. Um, However, now remember when we were searching for a creating factor list in Unit 5, I taught you multiple ways. You could do it through a factor tree, or you could do it through that factor arc. Um, for finding the greatest common factor, we're going to have to go back to our factor tree method. Okay, so we have to recall, how did we create factor trees? So we're going to break that back down, and I'm going to show you how that helps you find the greatest common factor. So when I'm creating a factor tree, I'm going to look at first 16. I'm going to do them each individually first. Okay. So if I'm going to 16, what times what gives me 16? So I'm going to say 4 times 4 gives me 16. Okay. Now, what times what gives me 4? 2 times 2 gives me 4. I have to do the same thing on this side. But remember, what did I tell you? When we're done, we circle our prime numbers because we're done with it. So I'm going to circle my prime number to let me know I'm all done with this. And I'm all done with this prime number. Just so you know, there's nothing more you can break down. This side is completely done. I'm going to break this down. 2 times 2 equals 4. And again, I'm just going to circle it to let me know I'm all done with this. Okay. So now I see it's completely done. It's completely factored out. This number is taken care of. I'm done. I'm going to move on to 20. Okay, 20. And again, I always like to, if I'm starting off with pulling out a prime number, I always put my prime numbers on my left-hand side. So I'm going to say 20 is 5 times 4. 5 is a prime number. Just to recall, remember, a prime number is a number where only it's divisible by only 1 and itself. 5 is divisible by only 1 and itself, so it's a prime number. So 5 times 4 is 20. Again, I circle this number to let me know this number is all done. I'm done with it. I can't do anything else with it. We're done on the left-hand side. 4 is we're not done with, okay? It's divisible by more than 1 and itself. So now I got to break it down further. We're going to say 2 times 2. 2 is a prime number, so now we're done with that. So I'm going to circle the 2. I'm going to circle this 2. And now I can see this number is completely factored. We're done. We pulled out all the prime numbers. We can move on to 24. So 24, again, if I can pull out a prime number right away, I always pull it out and put it to my left. So I'm going to pull out, I'm going to say 3 times 8 equals 24. I circle my prime number. So now I know my left-hand side is completely done. 8, I'm going to say, again, put my prime number on my left-hand side. I'm going to say 2 times 4 equals 8. I'm going to circle that prime number. I know my left-hand side, again, is done. But 4, I can keep dividing out. 4 is 2 times 2. Now I know both of these are prime numbers. I circle it, and I'm done. So I created the factor trees for the 3 numbers. That's step 1. Okay. Remember, though, I'm asking you to find the greatest common factor. So what do they have in common? So step 2. Now I got to look at all the prime numbers I circled. Okay. I see 2's over here. I see 2's and a 5. But right away, I know this 5 I have to cross off because there is no 5 over here. So can it be a common factor? No, because 16 does not have a 5. So 5 is not common. Okay. Remember, all 3 of them have to have it. So now I see 2's here. I see 2's here. I see 2's and a 3 here. There's no 3 here. There's no 3 here. So 3 is not in common. Cross that out. Now circle back to our 2's. I see 4 2's here. I see only 2 2's here. Okay, there's only 2 2's here, so I have to cross off 2 of these 2's because they only have 2 2's over here. So there's 2 2's in common with these 2 2's. There's 1, 2, 3 2's here. I gotta cross off this 2. So now, do I have the same common factors with all 3 numbers? Let's check. I have 1 2, 2 2, 1 2, 2 2, 1 2, 2 2. Okay, still not done. All right, so that was step 2. Step 3, so I'm looking for my GCF. So GCF would then equal, it's 2 times 2, because you have the 2 2's. Okay, 2 times 2 is 4. So your GCF is 4. Okay, so that they're the 3 steps that you have to go through to find your GCF. Okay, step 1, you create your factor trees. Okay, when you create your factor trees, you pull out all your prime numbers. Step 2, then you have to go through all of your prime numbers and circle the prime numbers that all 3 numbers have in common, because you're looking for greatest common factor. Step 3, the reason why you multiply these together is you're looking for the greatest. So it's the greatest. So it's 2 times 2 is 4. Okay, so it's the greatest common factor. I do want to show you one more example and explain to you the reason why we choose factor trees over trying to do like a rainbow arc. So factor trees, again, they help you with larger numbers. A rainbow arc would take you, or a factor list would take you a really, really long time to figure out all of the numbers. So it really, doing prime factorization, creating a factor tree is the easiest way, especially if you're given a really, really large number, which on like a Keystone exam, most times you're not going to see something so simple. They'll probably throw you something with a larger number. Okay, so let's just try it. So I know this is all new, but I'm going to show you something that you would probably more likely see with something with a larger number. All right, so we definitely need our calculators out for this because they're big numbers. So you want to make sure you have your calculator out and handy. And 1, we always say, is creating that factor tree. Where's my water bottle? I can't find it. All right. So when I'm looking at this, I think I'll pull out a 24. And 24 goes in 26 times. Double check that with your calculator. I'm pretty sure that's, yeah. 24 times 26 would give you 624. Okay. Now, obviously, these 2 numbers, you're going to have to break down quite some. So now we're going to start with the side of 24. So for something like this, you're going to have to leave yourself a lot of space to keep breaking down. 24, you can pull out a prime number right away. So again, I always pull out my prime numbers to the left-hand side. So I'm going to pull out the 3, which is your prime number. And I'm going to pull out an 8. I'm going to circle my prime number. I choose to deal with, I don't move on to the next one until I finish one side. So I'm going to leave that 26 alone until I complete the side. This way I don't miss anything. So now 8, I'm going to pull out my prime number of 2. I'm going to circle it. And 2 times 4 gives me 8. 4. 2 times 2 gives me 4. Circle my prime numbers. Now I see I'm done with my left-hand side. It's done. So I'm going to move on to my right-hand side. So 26, you can pull out a prime number because it's 2 times 13, right? And 23 plus 3 is 6, yes. So this one was easy. They're both prime numbers. You circle them. We're done. So as you can see, it's completely done. We can leave that be and move on to 836. 22. 22 and 38. Is that what we're going with? So double check that in your calculator. And 22 is another super duper easy one. 22, 2 times 11 equals 22, and they're both prime numbers. So I'm going to circle both the 2 and the 11. It's really hot in my attic. I'm sorry. Yep. And then, okay, this one's pretty easy too, because 2 goes into this. 2 times 19, right? 9 plus 9 is 18. Carry that. Yep, we're good. So they're both prime numbers. All right. So this one was an easy one. Super duper easy one to factor out. So now, greatest common factor, we go back through. So now we did our factor tree. And now I have to look. Oh, let me get my purple to cross off. Is there a 3 on this side? No. Is there a 2 on this side? Yes. So I can leave the 2 for now. Is there a 13 on this side? No. Is there an 11 on this side? No. Is there a 19 on this side? No. Okay, so now we gotta go back to the 2s. I have 1, 2, 3, 4 2s on this side, only 2 2s on that side. So I'm crossing off 1, 2 of the 2s. So it just so happens the greatest common factor for this one is the same thing. So GCF would be, you see, you have 1 2 over here, 2 2s over here, 1 2 over here, 2 2s over here. So GCF is 2 times 2, and that equals 4. So your GCF of 624 and 836 is 4. Okay, so that would be how you would do it for a larger number. You would definitely need your calculator for a larger number. But I just want to give you an idea of what a large number would look like and why we use prime or a factor tree to do this. Okay, because it's a lot easier to do it through a factor tree. All right. So I hope you have a wonderful day. And if you have any questions or concerns, which you might with this lesson, please feel free to reach out to me. All right. See you later. Probably going to take an air conditioned break and I'll be back. Bye now.